Hi there. Today we will learn circle chapter and it is important chapter for class 10. So there are two portions for the circle in class 10th and actually there are two chapters in class 10 that are related to circle. First is from the mensuration section and another is from the geometrical section. Today we will cover the circle from the mensuration section. And here we will learn to find out the area of a sector and segment. So let's start. We'll begin the class by putting the definition of a circle. So what is a circle? So circle is a simple closed curve in a plane where each point on the curve is at the same distance from a given point called center. For example, this is a circle and the inside point, this inside point O, it's called the center. It's a given point, it's called center. Generally it is represented by letter O. So if we take few points on this circle, let's say it is point A, B, C and D. So these all 4 points will be at the same distance from given point this given point center. So if, let's say, this distance between point O and C, it is 2 centimeter, for example. So this distance between D and O, it is also going to be 2 centimeter, and same goes for the O and B and O and A. These two distances will also be 2 centimeter. Okay, so we are saying that every point A, B, C, D is at the same distance from the center O. So this is just the basic definition of a circle. Now there are many terms related to circle that we need to know, and it might be possible that you may be familiar with these terms already in your previous classes. Here we will try to define it. So our next term is radius. So the distance between any point on the circle and the center is called the radius. Generally, we represent radius with letter R. So, for example, this is a circle, and this is the center O, and let's take any point on the circle. Let's say it is point P. So distance between this center O and this point P on the circle is called the radius. So this distance PO, it is called the radius. Okay. Now the next term is circumference. Circumference is generally represented by capital letter C. So what is a circumference? So circumference, it is the length of the boundary of a circle. Okay. Okay. And you can also say that it is a perimeter of a circle. For example, you can explain it by taking a circle. Let's say this is a circle, and I'm marking some point on the circle, point A, B, C, and D. So this boundary A to B, then B to C, and C to D, and the last D to A. This boundary ABCD, this curve length is the circumference of the circle. Circumference of a circle is generally represented by capital letter C. And we also have a formula to calculate the circumference of a circle. The formula is 2 pi and r. Okay. Here r is the radius. And pi is a constant. So value is 22 by 7, or it could be 3.14. So by using this formula c equals to 2 pi r, we can calculate the circumference of a circle. Now the next term is the chord. So chord is a line segment on a circle which joins any 2 point. So we can write the line segment which joins any 2 points on the circle is called chord. Let's take an example to understand it. So this is the circle, and I have this 2 point here, point A and B. So if I join these 2 points with a line segment like this will be a chord. And here's the center of this circle O. And we can take one more chord. Let's take another point D and C. So if you again join this, it will be another chord. So this line segment AB and this line segments BC, these are the chords. A line segment is represented by this, like this. You need to draw a straight line and put the curve at the end of this line. So if we draw many chord on a circle like this, if you draw many chord like this, so you will realize that as you get closer to this center O, then you'll find that the length of this chord is also increasing. Okay, and if you move away, the length of the chord will decrease. Okay, so The longest chord that we can have in a circle will be the one which is passing through the center O. This will be the longest. And actually we have a name for it. It's called the diameter. Okay. So the longest chord on a circle will be the one which is passing from the center O. Okay. So you can write it. The chord which passes from the center is the largest. Okay. And this largest chord is called the diameter. So the next term is the diameter. As we already know, the largest chord of the circle is called the diameter. Or you can also say it another way, like the chord passing from the center is called the diameter. Now you can say it another way. The chord passing from the center is called diameter. Okay. For example, let's take O center and let's draw a chord passing from this center O. Let's give it some name, point A and point B. So this length AB is the diameter. It is diameter. Generally, diameter is represented by capital letter D. Okay. So this length AB, you can write this uh, length AB like this. AB equals to the distance AO and the distance OB. If you add them, you will get the length AB. And we already know that distance AO, that means the distance between the center and a point on a circle. This one is, this AO is the radius, and similarly this OB is also the radius. So we can write AO, the radius R, and this OB is the radius R, this is D. So we can have a relationship between a diameter and a radius. So diameter is 2 times of the radius. D equals to 2R. Okay, so you can say the diameter is the 2 times of the radius. Now the next term is the tangent. So what is a tangent? Okay, it is a line that touches the circle at only one point. Okay, so let's understand this with an example. So this is a circle, and let's say I'm taking a point on a circle. Let's say it is a point A, and if a line just passes from this point A and it just touches the circle, it will not intersect it, just touch it like this. Okay, so this line CB is touching the circle at only one point, that is point A. So this line CB is the tangent. And now the next term is the secant of a circle. So it is also a line. The line that intersect the circle at 2 points is called the secant. Okay, so tangent will just touch it, it will not intersect it. It will touch only one point of a circle, but the secant will intersect the circle at 2 points. Let's understand it with example. So this is a circle with center O, and this is the line intersecting this circle at 2 points. Let's say this is the point A and this point D. Okay, so this line AD intersecting this line, well, give it some another name. E. Okay, so this line CE intersecting this circle at point A and point D. Okay, so this line CE is the second. Okay, next term is the arc of a circle. What is the arc? Arc, it is just a piece or the part of the circle. The piece or part of a circle is called the arc. Okay. For example, this is the just arc with the center O. Okay, it will be just a part of circle. I have not drawn the complete circle, but you can see this is the part of a circle. Okay, this is the arc AB. Let's give it some name. The endpoints, point A and point B. This arc, this is the arc AB with the center O, and it is the part of a circle. You see, from here to here. And generally it is represented by this. Write the int letters and a curve over it like this. This is arc AB. Okay. So if you see in this figure, you can see that there are actually two curves. One is at the below and one is above. Let's draw it separately. Actually, one needed to be draw a little bit bigger so that we can make comparison. Okay. You see, we have two arc. One is above the center and another is below the center. So you can see that this upper one have the larger length than the lower one. Okay. So the arc with the larger length is called the major arc. This upper one is the major arc. And the arc with this smaller length or lesser length is called the minor arc. This down one is called the minor arc. Okay, so we learned that the arc with the larger length is called the major arc, and the arc with the smaller length is called the minor arc. Now the next term is the central angle. Okay, so what is the central angle for an arc? So the angle subtended by the arc at the center is called the central angle. The angle uh, subtended called the central angle. Let's understand it with example. Okay. So this is an arc AB, and to find the central angle made by this arc at the center O of this circle, you need to join the end points of this arc. Join the end points, point A to the center and then point B to the center. So this angle, okay, this angle AOB, that is this angle AOB, this angle is called the central angle. So let's represent it with a letter theta. So this angle AOB, okay, this angle AOB is called the central angle of the arc AB. Okay. Now the next term is the sector. Okay. So sector is basically the region bounded by the arc and its two radii. The region bounded by arc and its two radii is called sector circle. Okay, let's say this is an arc. Okay, this is an arc AB, and to the center of the circle O. So this region, the arc AB and its two radii AO and OB. Okay, this complete region is called the sector of the circle. Okay, so in this diagram also we have two sector. Okay, in this diagram also we have two sector. One is this one, another will be the left one. That is left. So let's draw it separately. This is the upper sector, and we have the down one also, which was the part of it. So you see the upper one, there are two sector, the upper one and the below one. Okay, you'll find that the arc length for the upper one is the larger, and for the lower one it is the smaller. So the sector having the larger arc is called the major sector, and the sector with a smaller arc length is called the minor sector. So this one is called the major sector, and it will have the major arc. This is one is called minor sector. It will have the minor arc. Okay, so we have almost completed every term, and this term is required to find the area of sector. That is why we discussed it. Now we will learn how to calculate the area of a sector. Let's let's take a circle with a center O. Okay, and radius R. Okay, so the area of this circle will be, it is pi r square. We know it from our previous classes. Okay, now let's take a complete angle in one rotation here, from here to here. So you will find that this angle at the center in one complete rotation, it will be 360 degree. Okay, so it means that when the central angle is 360 degree, then it will be covering all the area of this circle. Okay, and it also means that when the central angle is 360 degree, then the area of the circle is pi r square. Okay, when central angle is 360 degree, then it is going to cover all the regions of the circle, and the area of the circle will be pi r square. So for 360 degree we have the area, it is pi r square. So if you want to find the area for just only 1 degree, it will be pi r square divided by 360 degree. Okay, we are following the unitary method. So for our sector we have a central angle theta. Okay, for our sector we will have this central angle theta. So if the central angle is theta, then it is going to cover only this much portion of the circle, and this portion is our sector. So we have already calculated the area or the region just for only 1 degree. So if the central angle is theta, then the area will be pi r square divided by 360 into theta. Okay, so this is the area of this sector. Okay, we can write it, area of sector equals to pi r square divided by 360 degree and into theta. Okay, and here r is the radius and theta is the central angle, and note that this central angle theta will be in degrees. Okay, and pi is the constant, value is 22 by 7 or 3.14. So using this formula we can calculate the area of a sector. Okay, now we will solve one problem to apply this formula. Okay, so let's solve a problem. The question is, in a circle of radius, let's say it is 21 centimeter, an arc subtends 60° at the center, then find the area of first minor sector and then major sector. Okay. So this is the complete question. In a circle, the radius is given 21 centimeter and the arc is subtending angle 60° at the center. Then we need to find the area of minor sector and major sector. Now let's solve this question. Okay. Let's say the arc is AB. And here the center, and it is given that the angle made by the arc at the center is 60°. It means the central angle will be 60°, theta will be 60°, right? 60°, and the radius is given, it is 21 centimeter. So this will be 21 centimeter and this will also be 21 centimeter. Okay, so we can apply the formula, this formula, to calculate the area of this sector, and it will be the minor sector. So first, area of the minor sector. Let's call it with capital A1. Okay, let's push the value. You see, we have the radius 21 centimeter, and if I take the value of pi 22/7 and the 7 is in the denominator, so I can cut down this 21 centimeter by 7. So that is why it is suitable to take the value of pi as 22/7 and not 3.14. So this is how you will choose the value of pi, depend upon the data you have given or the question has asked you already. So if you find anything is there that can be cut down with later with the number 7 or 22, so it is better to use the value of pi as 22/7. And this is not the case, then it will be better if you use the value of pi as 3.14. So it totally depends upon the data of the question that is given. The radius is 21 centimeter. Okay. So need to just simplify it a little bit. Let me write it with a better way. So now simplify it. Can cut down this 0, and 6 1 just 6, and 6 6 ja 36, and 7 1 ja 7, and 7 3 ja 21. Okay. So now let's write what is remain. 22, 3, 21, and 1, no need to write it, and 6. We can also cut down this 22 and 6 with the table 2. So 2 times 3 is the 6, and 2 times 11 is the 22. Now again you can cut down this 3 and this 3. Now what is remain? It is 11 and this 21. So if you multiply it, it will come 231. 230. Also write the unit for the area. It will be centimeter square. So we have calculated the area of the minor sector, and it is coming 231. Okay. Now we will calculate the area of the major sector. You can do it by two methods. First is by subtracting the area of minor sector from the whole area of the circle, and another is by finding the central angle of the major sector and then apply the formula. I'm telling here the first one. So you see, in this circle we have calculated this area, the minor one. So if from whole the circle, if you take out this smaller one, then the remain will be only this, and this is the major sector. Okay, this is the major sector. So that is why if you subtract this minor sector from the whole area of the circle, then the remaining area is our the major sector. So we can write it that area of major sector will be equals to area of circle minus area of minor sector. Okay, let's call the area of major sector with the letter capital A2. Area of circle, we can write the formula for it. It is pi r square. And area of minor sector, we have already calculated it. It is A1. Okay. Now let's push the value. Again, we'll put the value of pi as 22/7 because the radius is 7. I can cut down the uh, denominator 7 with radius 21 centimeter. It was 321, right? So it is 231 centimeter. Now this we have to do it. Now multiply this 22 with 3, it will be 66, and then multiply this 66 with 21. It is 6 times 1 6, and again 6. 6 times 2 is 12, and carry 1. 6 times 2 is again 12, and then carry 1 13. It will be 6 8 1 and 3. So 1386, and just 31. Now let's subtract it here. This 231 from it will be 5 5 1 and 1. So the final answer is 1155 centimeter square. Okay, so we have calculated the area for the major sector also, and it is coming 1155. This is the first method. You can also apply the formula to calculate it. I'm just showing it. Now the second way you can calculate it by finding the center angle for the major sector. So this angle was the 60 degree, and we know that in one complete rotation at the center, the angle will be 360 degree. So if I want to find the angle here only, it will be the, okay, this will be the center angle for our major sector. So it will be 360 degree minus 60 degree, so it is coming around 300. Okay, 300 degree. So this angle is 300 degree. So if you take this central angle 300 degree and apply the formula of area of sector that we have just found, then you will again get the same area, 1155 centimeter. Okay, and I'm just writing the value. You can make the calculation. Here the theta is 300 degree and value of r is 21 centimeter. Now you put the formula. I put this value in the formula in this and calculate it. You will again get the same area. Okay, this is the second way you can solve it. So that's all for the today's class, and the next one we will solve the area for the segment. Okay, that's all. Thank you.